purpose of this build is to satisfy the many inquiries within my community about building horned enclosures. Also, I've been curious about some of the enclosures I've seen built on YouTube claiming to be horned enclosures. In my opinion, most of these so-called horned enclosures are way too small for the 12, 15, and even sometimes 18-inch drivers that they are designed for. From my experience, you have to have a tremendous amount of volume to achieve the bandwidth associated with a properly designed horn enclosure. Otherwise, you're simply building one-hit wonders. So in this video, I will build my own enclosure using a tiny 6.5-inch driver to display the true size of a properly designed horn enclosure. The goal of this build is to design a horn enclosure that plays 30 Hz lower than the subwoofer's FS rating. In my case, the subwoofer I'm using has an FS of 58.9 Hz. I plan to effectively achieve an F3 of around 30 Hz or so. So now that you know the purpose of the build and the goal of the build, what is the purpose of the video? Well, in a recent poll, I asked what type of subwoofer enclosures would you guys like to see me build? An overwhelming majority said horn enclosures. And since it's my responsibility to give you guys the content that you request, in this video I'll show you all the steps necessary to build a horned enclosure. Over the years, I've learned that it is best to design my projects in a digital space first. That's before spending my hard-earned money on building materials and such. HornResp is a free software program developed by David McBean. It is described as a direct radiator and horn-loaded loudspeaker simulator that is used for designing horn enclosures. But please keep in mind there are many different types of horn enclosures. In our case, we're designing a rear-loaded horn enclosure using a single CT Sounds MESO 6.5-inch subwoofer. Anything featured in this video, you can find links to it in the descriptions below. But first of all, what is a back-loaded horn enclosure and how exactly do they work? A traditional ported enclosure produces sound by building up pressure inside its cabin, which is then forced through a port, which in turn is tuned to a specific frequency. This type of enclosure is also known as a bass reflex design. Horn enclosures have three main parts to focus on. You have the throat, the neck, and the mouth. And you can simplify this by saying the beginning, the middle, and the end. To be more specific, back-loaded horn enclosures do not incorporate a cabin in which to build pressure into. Instead, the sound waves are guided down a line and amplified by either growing or shrinking the line itself. In this style of enclosure, bass is admitted into the throat of the horn mounted at the back of the driver, and all frequencies radiate directly from the driver down the neck and out the mouth of the horn. If designed properly, not only will a horn enclosure produce more output than a bass reflex enclosure, it will also achieve this output while receiving less power. So in short, they are more efficient than a bass reflex enclosure. Our final design have a line length of 118 inches and requires 30% of the line to be treated with acoustic padding. The dampening is required to achieve a flattened response of around 30 to 70 Hertz. Once we have our measurements for port area and port length, we can then start the modeling phase of our enclosure using SketchUp. Alright guys, so right now we over here in SketchUp, and what you guys are looking at is a 3D rendering of the horn enclosure that I just built for the 6.5 inch subwoofer. As you guys can see, the port on this thing, or the line on this thing, is very, very long, and it gets progressively larger or wider as the line grows. And at the mouth of the enclosure, you have 1 foot, that's 12 inches. For anyone who was curious about that. Over here, the blue area is representing the internal volume of this enclosure, which is 3.8 cubic foot. Over here in this blue shaded area, you have how much space does the entire enclosure take up in your trunk? 5.3 cubic foot. Once again, this is a very large subwoofer enclosure for one single 6.5 inch subwoofer. Right now, what you guys are looking at is a 3D representation of the trunk space of my Chevy Impala. If you guys are curious of how much available trunk space we have, you have approximately 18 cubic foot of available trunk space. Moving on, you will see a digital representation of what this enclosure would look like inside that available space. And yes, I had to relocate my amplifier just to make this thing fit. For this build, I chose to go with MDF. Yeah, I know it's a lot heavier than plywood, but it also has a superior sound signature. For the top, the bottom, and the baffle of this enclosure, I used 3/4 inch MDF, but all the other walls and internal ports were constructed of 1/2 inch MDF. I then simply followed the cut guide developed over here in SketchUp and soon had a flat pack to assemble. I used glue and brad nails for my build and large clamps to keep everything in place. And once everything is dry and all the clamps are removed, this is what you should be left with. In terms of SPL, I have no idea what the output of this enclosure is going to be. I know that waveguide builds like this are known to be efficient, but not sure about the pressure level of them. As previously stated, the goal of this build is to design a horn enclosure that plays 30 Hz below the subwoofer FF rating. So let's grab all the necessary tools and see if this enclosure lives up to my expectations. All right, guys, so we're back here in the Impala testing the power and response of this horn enclosure. This is a single CT Sound MESO 6.5 inch subwoofer, and this is loaded into a rear firing folded horn enclosure. That enclosure measures 31 inches in length and 40 inches in width. It takes up my entire trunk. To test this, we're going to be using the mini bass meter by SPL Labs. And we have the SMD AMM1 to measure real world output. To power this system, we're going to be using the TAR amps MD 8000.1. And all of this is being fed through the LC2I by audio control. So let me find my mode for real power. We just want to monitor the power to protect the subwoofer. This amplifier would easily bust this subwoofer, and we don't want that to happen. And the test is going to involve a bass sweep. I'm going to sweep it from 150 all the way down to 20 Hertz. I want to see the response of this. And I also want to catch what my maximum decibel or SPL value is and at what frequency. That's the whole purpose of the bass sweep. So let me get this going and give it some power. So I'm gonna hit play. All right, so what we want to know now, we want to know our peak value. Right now that value is, it has an SPL value of 127.3 decibels. Now we want to know at what frequency did it get that. So what you got to do, toggle through the mode at 37 hertz. So 37 hertz is our peak. That's basically where we'll be running our test, 37 hertz. Okay, so what we're going to be doing now is we're going to be going up to 37 hertz, which is where it peaked. We're going to be running this test again. We're going to hit play and we're going to give it more volume. This subwoofer has a RMS rating of 400 watts. I'm going to try not to exceed that much because it's in an open environment. It has really no back pressure and it will damage the subwoofer in this waveguide enclosure. So what I'm going to be doing is I may just do it until it maxes itself out and then we'll read the results of that. All right, so this is 37. That's impressive. I'm gonna put it on dyno. That's dyno power. And I'm gonna see what its peak value is. Sometimes your eyes can't see. So I'm gonna take it all the way up until it reaches its mechanical potential, till it bottoms out, and I'm gonna see what value it holds. Wow, man. That is impressive. 750 watts, and I think this thing had a little bit more in it. The ticking that I heard previous was in the environment. It came from the panels in the car, not even the subwoofer. As you guys can see, this little subwoofer has a lot of mechanical potential. And I think I'm gonna reset this. And I'm gonna take it all the way up again. Let's get it. Wow. Wow, wow, wow. And that's it. I'm gonna stop this. And we only still have a 133 dB. Very impressive for one little bitty sub. Wow. So tell me in the comments, did you guys think that this one little subwoofer would give you almost 135? I did not. It blew all the, I didn't even know it had that much sawdust in it. It blew all the sawdust out. Look at this. All that dust came out of there. One little bitty guy. All right, so as you guys can see, it did very, very well on the sine wave, but what does it sound like on music? We'll be doing that next. Another thing I want to point out, guys, is this. This is easily a 135 SPL score, and I'm going to tell you why. The cabin, this thing is forward facing into the cabin, meaning that this port really has nothing to load off of. If I had the energy to turn this thing around, which I'm not, I think you guys, you more experienced guys especially, already know that if it was to load off the trunk, that'll be a 135 easily. Maybe even more than that. I'm curious to see what it would do. Maybe in a future video I'll throw it in as bonus content. But for now, I consider this a success. And if you guys have ever been interested in doing a folded horn enclosure, I say go for it. It has tremendous output, very, very efficient, and this thing just scored practically a 135. If it was to load off the trunk, you know it would get there. Very impressive. I recommend this enclosure, this style of enclosure, I should say. If you have space for it, I recommend it. now that we've tested the subwoofer enclosure without sound treatment, what we're going to be doing now is adding some dampening material there. This is supposed to give us a flatter response in between around 30 and 75 hertz. Now keep in mind that we will lose a little bit of output. By sacrificing that output, what we will gain is sound quality. All right, guys, so we're back here in the Impala, and right now what I'm going to be doing is a bass sweep after installing the installation inside of that box. See if we can even tell the difference on camera of this being a flatter response or not. So I'm going to get this back up to around 100 hertz or so. I'm gonna hit play and see if we still get those major peaks like we did before, or whether or not it stays consistently flat. So I'm gonna hit play and just slowly decrease it. All right, we registered a 125 on the SPL scale. Let's see at what frequency that is. Last time it was 37 hertz. Let's check it out. Same thing, that's my cabin peak. Let's go back. So we know it's still 37 hertz, which isn't bad, but to me, it does seem a lot more flatter. You don't have that big peak that we used to get in those two different locations around 30 hertz. We used to get a major peak, and then we also used to get a peak around I want to say in between 65 and 70 hertz. We used to get like a big peak, and that peak is almost gone. It's almost flattened, but we still do get a peak at around 34 hertz or so. I'm gonna run it again with a little bit more juice, a little bit more power, and we're gonna see if we can notice those a little bit more. Okay, it's back at 99. Let's get it. Wow. Very low power, man. Very low power. And it's sounding amazing. So let's reset this back to 37. Okay, now that it's at 37, I'm gonna turn it up and see if we can get it up to around 800 watts again and see what the results will be. Turn the bass knob down and hit play. And let's get it. Oh man, that thing went off again. Dang. All right, so now that I got this thing back reset, let's try this. Y'all already know my love-hate relationship with this tool. Great tool, but it got a horrible cutoff feature that I hate it. But anyway, let's do this. We have 37 hertz. We're gonna try to get it up to around 800. 400 to 800. 800 is the peak. Let's get it to 800. If it can take it, I doubt it. Wow, man. Wow. Boy, that little speaker take all that power. It's a 130. It's not the 133 that we previously had, but I'm impressed with that because now I have a flatter response, guys. And of course, anytime you stuff the tube, you do lose some output, which we all knew that was going to happen because the software told us it was going to happen. Put the stuffing in there. I should stop saying stuffing. The acoustic material on the inside of it it flattens out the response, but of course the sacrifice of that is you lose a little bit of output. In this case, I lost 3 dBs, which is noticeable. 3 dBs is right at the human ear, capability of being noticeable. But it's okay, it sounds a lot better, it's flatter. Let's see what it sounds like on music. Now this song right here got a lot of different bass drops in it. I like it. It covers a wide variety of frequencies. Hopefully you guys enjoy it. I like those bass drops. Here's another one of my favorite with a lot of dynamic beats. Well, as you guys see it for yourself, this little guy here is doing well in this enclosure. Like I stated previously, this is a very large enclosure, but man, hey, it is what it is. It performs. Gets my approval. I like it. Now let's talk about the pros and cons. First, we're going to start off with the cons. Size. Unfortunately, the size of this enclosure is too large for a single 6.5-inch driver. Yes, I mean, it sounds amazing. And yes, it's low profile, but the output simply isn't enough to encourage me to use this in my automobile. Installation. Man, installation of this enclosure really requires 2 people. I mean, after all, it takes up the entire floor of my vehicle. Now, I was able to do it alone, but this is definitely not something that I would like to do again. The width of the enclosure was a bit much and actually took some modifying to make it fit. I mean, I literally had to remove my amplifier and place it on top of this thing. So if you plan to use this design, you may want to install removable handles in order to ease the installation process. Now let's talk about the pros. Space saver. As previously stated, the Chevy Impala has a cargo volume of 18.8 cubic foot. This build totaled 5 3/8 cubic foot, which means that I got to keep a little bit over 70% of the available trunk space. And to my opinion, that's a win-win. SPL. I was genuinely shocked at the SPL results of this build. I had no initial goal of registering anything worth filming and instead walked away with a near 135 dB test score. So let me know in the comment sections below what you guys thought about this build. Would this be something that you would incorporate in your own vehicle, or will you give it a pass? Let me know in the comment sections below, and as always, anything featured in this video, you can find links to it in the descriptions below. Love you guys, and peace. I'm out. Thanks for visiting the channel to help you simplify car audio. It's the Budget Basshead, and I'm out.